Good morning, children. Today we have got the discussion of physics, 30 questions, chapter 10, mechanical properties of fluids. First one, the velocity of a small ball of mass m and density d when dropped in a container filled with glycerin becomes constant after some time. Density of glycerin is d by 2. Then viscous force acting on the ball will be. This is a question from 2021 Neet paper. Here, the density of glycerin is d by 2, where d is the density of the ball. The ball is acted upon by its weight, buoyant force, upthrust, then viscous force, Fv. As velocity is a constant, that means acceleration is 0. That means for balancing of forces, U plus Fv is equal to mg, so that Fv, viscous force, is equal to mg minus u. That is equal to mg minus u means that is upthrust. Upthrust can be written as weight in air multiplied by density of liquid divided by density of solid. That is equal to mg multiplied by 1 minus rho L by rho S. What is rho L by rho S? That is 1 by 2. It is given. So that answer is mg by 2 apple. Next one. A capillary tube of radius r immersed in water, and water rises to a height h. The mass of water in the tube is 5 gram. Another capillary tube of radius 2r is immersed in water. Mass of water that rises in the tube is. The mass of water dependence over its radius, that is to be found. Here we know capillarity h is equal to 2s cos theta by r rho g. H proportional to 1 by r. But for finding mass of this tube is a small cylinder. Mass is equal to volume of liquid inside into its density. Volume is pi r square times h, where h is the height to which water rises in the tube. Tube is cylindrical. Water rises to this much of height, and this forms a cylinder of height h. Its volume is area into height pi r square h times the density. It is clear mass proportional to r square times h, but h is already proportional to 1 by r. That is why m proportional to r square multiplied by 1 by r. You can cancel r. So m varies directly with r. The relationship is linear. Radius doubled, then mass is also doubled. So the correct answer, it should be 10. Third one. Soap bubble having radius 1 millimeter is blown from a detergent solution having a surface tension of 2.5 into 10 power minus 2 Newton per meter. Pressure inside the bubble is equal to at a point Z0 below the free surface of water in the container. Suppose you have a container. Take the case of a container. Take the case of a container. This is that container. Water is up to here in that container. And here the pressure is atmospheric pressure, PA. And here is a point which is at a depth Z0. What is the total pressure at this point? That pressure is PA plus Z0 rho g, where rho is the density of water. Okay, and it is given that is equal to the pressure inside the bubble, soap bubble. Pressure inside the bubble. When a soap bubble is kept in air, okay, surrounding pressure is atmospheric pressure. What is pressure inside? For knowing the excess pressure, P in minus P out, that is equal to 4S by R. As the soap bubble has two free surfaces, you have to use the formula for excess pressure inside soap bubbles. Soap bubble is in air, 4S by R. That is P inside is equal to P naught plus 4S by R. Okay, that is equation number 1. Let this be equation number 2. Now, these two pressures are given to be same. That means 1 is equal to 2. That is, P0 gets cancelled. You will get 4S by R is equal to Z0 rho g. Then Z0 is equal to 4s divided by r rho g. Direct substitution, 4 multiplied by 2.5 10 power minus 2 divided by r, which is radius, 1 millimeter, convert into meter, density SI, 1000 kilogram per meter cube, G value given to be 10. Okay, so you'll get the correct answer is 1 centimeter. Next one. Small sphere of radius r falls from rest in a viscous liquid. As a result, heat is produced due to viscous force. Rate of production of heat means rate at which heat is produced means the power. The answer is expected to be in watts. Okay, so power. Power is equal to viscous force multiplied by velocity. Power is the rate at which heat is produced. That is the product of force and velocity. Force is viscous force, that is 6 pi eta rv multiplied by v, that is power proportional to r multiplied by v square. But it's a very intelligent question. See, v already proportional to square of radius. So v square proportional to r raised to 4. So p proportional to r raised to 5. So the correct option is A. Answer option A is the right answer. Fifth one, at U2, both ends open to atmosphere, is partially filled with water. Oil which is immiscible with water is poured into one side until it stands at a height 10 millimeter above the water level on the other side. Everything is mentioned in the picture. That's why the question is very clear. You need to apply the concept. Meanwhile, water rises by 65 millimeter from the original level, density of the oil. Let us examine the picture. The original level of water, let me indicate using this red dotted line. This is the initial level. Okay, now oil which is immiscible with water is poured, which compresses the left arm. Okay, now water level in the left arm goes down by 65 millimeter. Okay, as the area of cross sections of U2 limbs are same. Also, water is incompressible. It rises through the same height in the other limb. So that water has reached this level. Now, that oil level in the other limb is higher by 10 millimeter, it is given. That also notified here. Okay. Now, what is the basic principle solving problems based on U2? That is Pascal's law. For applying Pascal's law, first of all, you have to choose a horizontal line where we have to equate their pressures. Okay. Now, let the pressure at this point be PC. At this point be PB. That two pressures are same as the level is same. In same horizontal level, fluid is at rest here. So we can apply Pascal's law. Pressures at same levels are same. Okay. How to apply that balance of pressures? What is pressure at B? Pressure at B is H rho G plus PA. That is PA plus H rho G. What is H? 65 plus 65 plus 10. That is 140. 140. That is 0.14 meter. H rho 10 power. That density is asked here, right? Density of oil is asked. Okay, PA plus that multiplied by G, that is equal to, what is the PC? That is PA, again at the open limb pressure is atmospheric pressure, plus what is that height? That height is only 65 plus 65 because water stops here. Okay, need not add 10. That is why it will be 13. So 0.13. There, that is water. So its density is 10 power 3 multiplied by G. Okay, here rho 0 you can estimate directly. That is 0.13. 0.13 multiplied by 10 cube divided by 0.14. PA and PA cancels. G also cancels from both sides. You will get this. And you can check the answer to be option D. Next one. Sixth, a rectangular film of liquid is extended from 4 by 2 centimeter to 5 centimeter to 4 centimeter area if work done is 3 into 10 power minus 4 joule. The value of surface tension. We know surface tension is defined as the energy per unit area. So the work per unit area. So work done in expanding to increase the area is equal to surface tension into change in surface area. surface tension into change in work done is equal to surface tension into change in surface area. Rectangular film of liquid, okay, that is work done. So work done how much? 3 into 10 power minus 4. 3 into 10 power minus 4 equal to surface tension is asked. What is delta A? Delta A, while we find, as it is a rectangular film of liquid extended from rectangular film of liquid does have two free surfaces. So don't forget to multiply by 2. 2 into what is the change in surface area? What is the surface area here? That is 8 centimeter square. What is the surface area here? That is 20 centimeter square. What is the change in surface area? That is 12. 20 minus 8, that is 12. 12 centimeter square. Convert that into meter square. 12 into 10 power minus 4. Then you find out the answer to be 1 by 4.25, 1 by 8. It should be option D. You can check T as 0.125. Seventh one. 3 liquids of densities P1, P2 and P3. P1 greater, P2 greater, P3. Having same value of surface tension T, rise to same height in 3 identical capillaries. Rises. It is given that rises. What is formula for capillarity? Capillary rise. 2s cos theta divided by r rho g, which is the popular Ascent formula. Here, 3 liquids of densities are different, having same values of surface tension. So S remains constant, 2 is constant, identical capillary means R is a constant, okay, G is again constant. Now, liquids having same values rise to same height. So height also is constant. So what all are variables? Density variable, that is why angle of contact is variable. It is clear, cos theta proportional to density. Okay, when cos theta proportional to density, when density is more, cos theta is more. But when cos theta is more, we know theta is less. That is why for larger density, theta will be less. So for larger density, P1 is greater. P1 is greater, so theta 1 will be least. Theta 1 least. Theta 1 least, so it cannot be. Theta 1 least. Theta 1 least, so it also cannot be. Now, theta 1 is least in each of these options. But it is also given rises to the same level. When rises to the same level, when capillary rise, angle of contact is always theta is less than 90. It will be between 0 and 90. So the right choice is option D. It cannot be option A. Next one, 8. A cylindrical tube of spray pump has radius R, one end of which has n fine holes, each of radius small r. The speed of liquid in the tube is V. The speed of ejection of liquid through the holes is. It's all about equation of continuity. This is a tube. Okay. Maybe here small holes. Here is that area. Okay. Multiplied by velocity. Area into velocity is a constant. Okay, rate of liquid flowing through this tube is a constant. Area into velocity is a constant. Here, what is the total area? Here, n number of holes are there, each having area small a into small v. So, equate these two. What is A? That is pi capital R square into V. V is the speed. It is given. Radius of the tube is R. So, its area pi R square. Speed of liquid in the tube is V. So, that is equal to n times. What is the area of each orifice? Radius of each small orifice is small r, so its area is pi r square multiplied by its speed v dash. So that v dash is equal to, you can cancel pi, you will get r square v divided by nr square. So r square v by nr square, option C is the right choice. A ninth one, a block weighs 360 Newton. Its dimensions are given 0.3 by 0.4 by 0.5. Ratio of greatest and least pressure. P max is equal to F by A min. Similarly, P min is equal to F by A max, because F is same. In whatsoever fashion the block has been kept over a surface, force is remaining same. Weight does not change if it comes in contact with greater area or lesser area. So P max by P min. Let us find P max by P min. P max by P min, don't forget when we take invert and you get A max by A min. A max by A min. Now it has become very simple. What is the maximum area from this combination? Here area length 3 into 4 12. Here 4 into 5 20. 3 into 5 15. Maximum area is 4 into 5. So 4 into 5. Sorry. 4 into 5 divided by, I am not using the decimals. Here, minimum area. What is minimum area? It should be 0.3 into 0.4. That is, I am writing 3 into 4. Okay, 4 cancels, 5 by 3. So, right choice is option A. Next one, 10th one. Equal masses of copper, aluminium, lead and gold are weighed in water. Okay, the which has greatest loss of weight. When a solid is immersed in a fluid, the loss of weight of solid in fluid is called upthrust or buoyancy. Upthrust or buoyant force. Upthrust is equal to weight in air multiplied by density of liquid divided by density of solid. Okay, here density of liquid is water. That is a constant. Equal masses of copper, aluminium, lead. That means weight in air is also constant. So loss of weight or upthrust inversely varies with density of the solid. The solid which has least density will has greatest upthrust. Least density one is aluminium. So it has greatest upthrust or greatest loss of weight. So loss of weight is more for aluminium. Next one. Cylindrical vessel radius r contains water. Height of water column so that force on the sides is equal to force on the bottom. Force on side, cylindrical water column, area, force on height of water filled up to some height, such that force on the sides equal to force on the bottom. Force on the bottom is equal to force on side. Force on bottom equal to force on side. What is force on bottom? Pressure equal to force by area. Force equal to pressure multiplied by area. Pressure at the bottom will be H rho G. Area of the bottom of base is circular. So pi r square. That is equal to force on side. Force on side equal to pressure into area, but that pressure is the lateral pressure. Water exerts sidewise pressure called lateral pressure. Lateral pressure is the average pressure. That is not H rho G but H rho G by 2. Lateral pressure is the average pressure multiplied by its area. Area is the curved surface area of that cylindrical column of water. That is 2 pi r h is the area of the curved portion of the cylinder. Curved surface area of cylinder. Okay. Now H rho G can be cancelled. Pi can be cancelled, 1r can be cancelled. Okay, these 2 cancels here, so you get H is equal to R. So option C is the right choice. 12th one. Weight of lead of relative density 11, which balances 8 gram of iron of relative density 8 when both are immersed in water. Okay. So this is the case, this is a balance, these are those weighing pans. Both are immersed in, it's a knife edge, both are immersed in water. Okay, one limb contains lead, other limb contains iron, and now both are balancing. That is, there is a counterpoise. Okay, now principle of moments can be applied. Apparent weight of lead block in water is equal to apparent weight of iron block in water. What is formula for apparent weight? Apparent weight is equal to weight in air multiplied by 1 minus density of liquid divided by density of solid. This is the formula for apparent weight. So apparent weight is equal to weight in air minus upthrust. That's the formula. Weight in air minus upthrust. Okay, as we have done in an earlier question today itself, weight in air can be, this can be written as weight in air into 1 minus rho L by rho S. Okay, then what is weight in air for lead? Weight in air for lead into 1 minus density of lead divided by sorry, density of water. Density of water divided by density of lead, that is equal to weight of iron multiplied by weight of iron in air multiplied by density of water divided by density of iron. Now substitution. Weight of lead is asked here. So weight of lead into 1 minus density of water. I am using CGS density 1 divided by density of lead. What is density of lead? 11 equal to weight of iron 8 gram, 1 minus density of water 1, density of iron 8. So this can be written as, let me write no room there, let me make room here. WPB into 1 minus 1 by 11 can be written as 10 by 11, that is equal to 8 multiplied by 1 minus 1 by 8 can be written as 7 by 8. 8 goes here. Now weight of lead is equal to 77 divided by 10, that means 7.7. It's a good question, you can try. 13. Pressure at the bottom of water lake is 3 by 2 times half of the depth. Water barometer reads 10 meter, the depth is. Okay, pressure at the bottom of water lake is 3 by 2 times half of the depth. Here we use the concept of water barometer. The calculations become much simpler. Height of water barometer is known to be 10 meter. What do you mean by that? Few kilometers of height atmospheric air can exert a pressure equal to that of water when its height is 10 meter. So 10 meter height of water can exert a pressure of air exerted by few kilometers, 5 or 6 kilometers of air column. Okay. Now here you can see this picture. Here is the depth. Here is atmospheric pressure. Atmospheric pressure is equivalent to a height of water column of 10 meter above that water. Okay, above this water column, air is there, but air up to few kilometers exerts a pressure as if it is water of height 10 meter. Okay, that we have learned. That is, what is the pressure at the bottom? Pressure at the bottom can be represented in terms of its height, because pressure only varies with height. 10 plus h. I am writing only pressure in terms of height. Okay, 10 plus h. That is equal to. So 10 plus h is the proportional pressure at the base. Okay, now that is equal to 3 by 2 times half of the depth. Half of the depth is here. Their height is h by 2. Half of the depth, what is that? For half of the depth also, this 10 is appearing there. So 10 plus h by 2. Okay, you can find h as 20 meter on calculating. You will get answer cat. You please try this calculation. Next, a vessel contains oil over mercury. A homogeneous sphere floats with half of the volume immersed in mercury and other half in oil. Density of the material, law of flotation, because a solid is floating in fluid. Then we apply law of flotation. You see how to apply this law of flotation. Let me divide that into equal halves. Okay, the total volume is V. Let this volume half, so V by 2, this also V by 2. Okay, now what is the total weight? Total weight is equal to volume of solid into density of the solid, that is to be as found, that is rho, that is equal to. I am not writing G because G gets cancelled. What is the upthrust? Okay, weight is equal to upthrust, that is law of flotation. Weight is written already, V rho. Upthrust, V by 2 into density of that liquid, that is 0.8, plus V by 2 density of the other liquid, that is 13.6. Okay, here V also you can cancel. You will get rho as the arithmetic mean. In such cases, you can choose the arithmetic mean of densities. Okay, you can try this calculation to get the answer C. 15. A glass bulb weighs 100 gram in air. Its density is 2.5. So what is its volume? Volume of glass bulb. Volume of glass bulb is equal to mass divided by its density, both in CGS. So you get 100 by 2.5. Okay, 100 by 25, it would have been 4. Now it is 40. So 40 centimeter cube is the volume of glass bulb alone. Okay, glass bulb, a thick glass bulb. The shaded portion is glass and inside is air. Okay, glass bulb weighs 100 grams in air. That means inside is already air, outside is also air. So its mass is 40 gram in water, right? 100 gram is the mass in air, 40 gram in water. That is the apparent weight is 40. Weight in air is 100, apparent weight is 40. So we can find upthrust. So what is the upthrust? Upthrust is equal to weight minus apparent weight. Weight is 100. 100 minus 40 is 60. So 60 gram is the upthrust. Upthrust is nothing but volume of water displaced multiplied by density of water. That is 60 gram. Okay, 60 gram. Now, volume of water displaced is equal to volume of glass. Volume of water displaced is equal to volume of glass multiplied by density of water is 1. So that is equal to 60. Okay. So volume of glass is 60. But here volume of the glass is 40. What is the difference? Here volume of the glass means volume of the material of the glass. Volume of the material of the glass. How much volume of material of glass is utilized for making this thick glass? Here, but this volume gives the volume of displaced water. Volume of displaced water means that is the outer volume that includes the volume of air inside. So this will be 40 plus 20 because 40 is the volume of the shaded portion alone plus 20 is the volume of air inside. So 20 gram of air is inside trapped. That is why 40 plus 20 is 60. So the right choice is 20. Okay, so volume of empty space or volume of air inside is 20. Next one. A wooden cube floats completely inside water when 200 gram of mass is placed and when 200 gram of mass is removed 2 centimeter above water level. Okay, we have this situation. You can see here side is 2 centimeter. Now, when 200 gram mass is removed, it rises above by 2 centimeter. That means when it was fully immersed, then another 200 gram mass was kept. When that 200 mass is removed, it rises up, so the 2 centimeter comes up. Okay, that what do you mean by that? This 200 gram of mass will be displacing a 2 centimeter height of water column corresponding to this cube. So volume displaced we have to find as in terms of upthrust. Okay, so we can use law of flotation. So 200 gram mass was able to be floating by 2 centimeter column of water. That is weight is equal to upthrust. That is 200 is equal to volume into density. 200 gram, that is equal to what is volume? Volume is area into height. Area of the cube. What is area of the cube? Area of one face of the cube, side square, into density of water. Density of water is 1. So 200 is equal to L square. You can make use of this formula into height. This is only area into height. Height is 2 centimeter multiplied by 1. So mass is equal to volume into density. Volume is area into height. Area L square, height 2. Okay, all in CGS. Density 1 gram per centimeter cube. That's why I wrote 1. Now L square is equal to 100. So L is equal to 10. So side of the cube is 10 centimeters. So I use law of flotation here. 70. Stone of relative density 5.5 is placed on surface of water. Acceleration with which stone falls through water is neglect the viscosity of water. Okay. So the neglecting the viscosity of water, there are two forces only. That is weight and upthrust. What is upthrust? In earlier two problems we have used this formula 1 minus rho liquid by rho solid. Now acceleration is downward. Acceleration is equal to net force by mass. What is net force? Net force is mg Sorry, here it is only this much. mg into rho L by rho s. Okay, it's not 1 minus. Up acceleration is weight minus upthrust. That is mg minus mg into rho L by rho s. That is mg taken as common 1 minus rho L by rho s. Okay, acceleration for finding you divide by mass. So direct substitution, G you can use 9.8, 1 minus density of liquid is water, density of solid is 5.5. 5.5 you can write 11 by 2, 11 by 2. Okay, that you can use 9.8 multiplied by 11 minus 2, that is 9, 9 by 11. That answer approximated to option B. 18. Excess pressure inside one soap bubble is 3 times that inside the second soap bubble. That is P1 is equal to 3 times P2. Their volumes are in the ratio. So excess pressure P proportional to 1 by R, but volume of a sphere, spherical bubble proportional to R cube, that is R proportional to V raised to 1 by 3. So P proportional to 1 by V raised to 1 by 3, that implies V proportional to 1 by P cube, 1 by P cube. So what is V1 by V2? V1 by V2 is equal to P2 by P1 all cube. What is P2 by P1? That is 1 by 3. So 1 by 3 all cube is 1 is to 27. Question number 90. A liquid drop of diameter D breaks up into 27 tiny drops. The resultant change in energy is, resultant change in energy. Change in energy is equal to, it is liquid drop, so 4 pi r square t into n raised to 1 by 3 minus 1. You can use this shortcut. It is a liquid drop, that is why here 4. If it was a soap bubble in air, it would have been 8, because there are 2 free surfaces for bubble, soap bubble in air. Here liquid drop in air, that has only only one free surface, that is by 4 pi r square t, where r is the radius. 4 pi into, answer is to be in terms of diameter. So r is d by 2, so r square is d square by 4, t into n is 27. 27 raised to 1 by 3 is 3, 3 minus 1. 4 cancels, so here you get 2 pi d square t. Really options are confusing, so care should be taken while doing similar ones. Spherical soap bubbles of radii R1 and R2 in vacuum coalesce under isothermal conditions. Under isothermal conditions, they join together. In vacuum there is no atmospheric pressure. Resulting bubble has a radius. How do you solve this? Here the process is an isothermal process because temperature is a constant. So 2 soap bubbles merge together to form a big one. Okay, there is no loss of mass of air inside, and also temperature is a constant. So we can use Boyle's law here. So P1 V1 is equal to P1 V1 plus P2 V2 equal to PV. So what is P1 V1? P1 is the pressure of air inside the bubble. Pressure of air inside the bubble is what? Excess pressure. Pressure inside is equal to excess pressure because outside pressure is 0. Excess pressure means pressure inside minus pressure outside. Here is vacuum, so outside pressure is 0. So excess pressure means pressure inside itself. That is 4, it's a bubble, so bubble in air. So 4, 2 free surfaces. So use 4 S by R1 into its volume is 4 by 3 pi R1 cube plus P2. Similarly, 4S by R2 into 4 by 3 pi R2 cube equal to P. P is what? 4S by R. Capital R is the radius of the final bubble, single bubble, into its volume. 4 by 3 pi R cube. So 4 by 3 pi cancels throughout. 4S cancels throughout, and also you can cancel 1 R1. That you get R1 square plus R2 square is equal to R square. So the right choice is option C. 21. A metal plate area given kept on a horizontal surface of layer of castor oil, thickness given, horizontal force required to move with a constant velocity. Here Newton's formula on viscosity, F is equal to minus a eta dv by dx. I'm taking the numerical value only. Area of contact, that is 500 multiplied by 10 power minus 4 eta viscous coefficient given in SI 0.9. Velocity gradient is dv by dx. What is dv? dv is 2 into 10 power minus 2. Don't forget that is in centimeter. Divided by dx, thickness, vertical height. This is the radial velocity gradient. Okay, radial velocity gradient is dv by dx. So thickness 0.5 millimeter. 0.5 millimeter you convert into meter. Okay, so finding out, get the answer box 22. Water contained in the tank flows through orifice of diameter given and a constant pressure difference of 10 centimeter of water column. So here is the orifice, water jumps out. Here is the height of water column, pressure difference 10 centimeter. Rate of flow of water through the orifice is. Okay, rate of flow of water, rate R is equal to area into velocity. Area into velocity, rate equal to area into velocity. So rate, that is in centimeter cube per second, equal to area into velocity. What is area here? Radius of the diameter of the orifice is given. So what is the area? Pi d square by 4. What is d square? 4 into 10 power minus 4 divided by 4. So I have written only area pi into diameter square by 4. That's the formula for area. Pi r square can be written as pi d square by 4. Okay, area into. What is the velocity? Velocity of efflux when the tank is open to atmosphere. Open to atmosphere, the speed of efflux to V is equal to root of 2gh, where h is the height above the orifice. Height above the orifice is 10 centimeters. So root of 2 into g into h. G I am taking as 980 or 10,000. Okay, I will take 1000. Okay, because I have chosen, I have chosen in SI. So no problem. I can take as 10. Here I have converted into SI. Okay, so root of 2 into 10 into 0.1. That you get 4 cancelled here. So 3.14 into 10 power minus 4 into this cancels root 2, 1.4. Okay, in doing that you will get the correct answer as option C. Next one. Cylinder is filled with water up to height a capital H. A hole is made at depth H below the water surface in the tank. Okay, this is the case. Water is filled up to height capital H. A hole is made at depth H below the water surface. Here is that hole. Here is the height H. Water coming out and strikes out here at distance S. What is S here? So S can be treated as the range of a horizontal projectile. This water streaming as a horizontal projectile. Okay, so S is equal to, you can use the range of the projectile, velocity into time of flight. Velocity is the velocity of efflux, that is root of 2g. Velocity of efflux is decided by the height of water column or liquid column above the orifice. Above the orifice height is h. So root of 2gh multiplied by velocity into time of flight. Flight time, that is decided by the height below the orifice, that is root of 2h by g. Time for free fall, root of 2h by g. Horizontal projectile also time to take down. Time to strike the ground is root of 2h by g. Root of 2h, that h is h minus h, remaining height. H minus h divided by g. G can be cancelled. That you get 2, 1, 2 can be taken outside. Root of h into h minus h inside root. So the correct option is B. 24th one. A gas cylinder, capacity given, filled at 2 atm. Pressure energy. Pressure energy of the gas is P delta V. P is 2 atm. Atm you convert into Pascal. Delta V 5 liter. Liter you convert into meter cube. 1 liter is 10 power minus 3 meter cube. So you get the correct answer 10 into 10 power 2. So 1000. Answer is cat. 25. Reading of pressure meter attached with the closed water pipe. Water pipe is closed. Suppose this end is closed. There the reading is 3.5 into 10 power 5 Pascal. Okay. Let that pressure be P1 or P2. Okay. Where tap is closed. So their velocity V2 has to be 0. So P2 is given V2 0 because it is at rest. It is stopped by the valve. By opening the valve, the reading reduces to. So opening the valve, the reading will be same as the reading here. Here water was entering and it gets stopped there. So what is the entering reading? That is 3 into 10 power 5 Pascal. That is P1. Their velocity V1, that is asked. So we can use Bernoulli's theorem for a horizontal pipe. Bernoulli's theorem you can apply. P1 plus half rho V1 square equal to P2 plus half rho P2 square for a horizontal pipe. That's why it does not have a gravitational head. Now here P2 is greater. So I am writing P2 minus P1 as half rho into V1 square minus V2 square, and V2 is 0 because valve is closed. What is P2 minus P1 here? P2 minus P1 is 0.5 into 10 power 5 equal to half into density of water 1000 into V1 square. So that V1 is equal to square root of 2 into 0.5 into 10 power 5 divided by 10 cube. That you get how much? That is V1 is asked. Here 10 power 5 comes. 2 into 0.5 is 10 power 5, and denominator you will get speed of water V1 is equal to root of 10 square, right? 10 raised to 5 divided by 10 cube, 10 square, that is 10. So correct answer is option 10 meter per second, 26th one. A hole is drilled at the bottom of tank in water. If the total pressure at the bottom is 3 atm, then speed of reflex. A hole is drilled here, so comes out. Total pressure here is 3 atm, but pressure exerted by atmosphere, you don't forget 1 atm is here. So here 3 atm means this pressure, the gauge pressure or excess pressure due to water column is only 2 atm. Okay. Therefore, speed of reflex equal to root of 2gh. That is root of 2 into g. I am taking 10. What is h? H will be 20 because 1 atm corresponded to 10 meter of water column from the concept of height of water barometer. Okay. Height of water barometer is nearly 10 meter. So 1 atm corresponds to 10 meter of water column. We have done the same concept in previous question also. So 2 atm means 20 meter. So 20 into 240 root 400 you will get 20. So the right choice is option D. 27th one. 1 meter long stick floats horizontally on surface of water. Surface tension is given. One side of the stick soap solution reduces the surface tension, then the net force on the stick. The problem comes out to be like this. You can listen here. Here is that stick. Okay. Here surface tension say T1. Here surface tension say T2. Okay. Suppose T2 is less than T1. Now these molecules on the surface of water will pull with a force F1. These molecules also will pull with a force F2. The length of that side is L. Okay, this side also of course forces are there. But these two forces are equal and opposite and cancel, so I am not considering that. Why? Because this here and here surface tensions are same. But these two sides only surface tensions do differ. It is given. So what is the net force? Net force is equal to F1 minus F2 because T2 is less, so F2 will be less. What is F1? F1 is equal to surface tension force equal to what is the formula for surface tension? Force per length. So force equal to surface tension into length. Surface tension is T1 into length is L. Next one T2 into length is L. So T1 minus T2 into L would be the correct answer. T1 minus T2 0.03. 0.03 means into 1 meter stick. So answer would be 0.03 Newton. Next one. Faulty barometer has some trapped air above mercury. Faulty barometer has some trapped air above. So why this barometer has become faulty? Because of the trapped air above the mercury column in this proposed Torricellian vacuum. But there is no vacuum, but some trapped air is there. Okay. So pressure exerted by the trapped air will determine the error in the reading. More the pressure exerted by trapped air, more is the error in the reading. Okay, when you carry this faulty barometer to higher altitudes, you know, their atmospheric pressure is less. When atmospheric pressure is less, the reading will be less. Reading will be less, right? When atmospheric pressure will be less, the mercury thread will fall. Then the Torricellian vacuum, proposed space of Torricellian vacuum would increase. So volume of trapped air would increase. When volume of trapped air increases, its pressure decreases. Why? Because of Boyle's law. The trapped air has constant mass. Assuming the temperature to be constant, we can apply Boyle's law there. So when this erroneous barometer is taken to a higher altitude, what happens? When the mercury thread falls, space above the mercury thread increases, that is the proposed space for Torricellian vacuum increases, but that means the volume of trapped air increases. So pressure of trapped air decreases. As the pressure of trapped air decreases, the error decreases. It's a very good question. Answer is box. 29. Water rises up to height h in tube replaced by similar one of half the diameter. Very simple question. H proportional 1 by r. When diameter is half, radius is also half. So height would be twice. Last one. Brahma press. The diameter of pistons are in the ratio 1:10. The force that is used in the smaller piston to raise the load of 1 lakh kilogram on the large piston is. See, that is 1 lakh. Right. Now the formula used is F2 by F1 equal to A2 by A1. Brahma press that works on the principle of Pascal's law. It's a hydraulic lift. Pressure on each of the limbs will be same. Small changes in pressures applied to any one of the limbs will be transmitted without diminishing throughout the liquid at rest. That's the principle as applied by Pascal's law. So F2 by F1 equal to F2 by A1. It's a very important concept for Neet. Okay, we have to know what is F2. What is F2? F2 is the force to be used on the smaller one. So A2 is the area of the smaller one. A2 is the area of smaller one. Area of smaller one would be what? Diameter of smaller one is 1. So A2 by A1 is 1 by 10, right? I'm choosing A2 as smaller one. So A2 by A1 1 by 10. Sorry, D2 by D1 1 by 10. So A2 by A1 will be pi r square, pi d square by 4. So proportional diameter square. So what's 1 by 100? So this can be chosen as 1 by 100 multiplied by F1. What is F1? We have to lift a huge load, that is 10 power 5. So it's 1 lakh. So this cancels and you get 10 power 3. So 1000. So you get 1000 kilogram. That is 1000 kilogram weight. So the correct answer is option B. Okay, right. Divided by 100, don't forget, because this is diameter. 1:10 is the ratio of diameter. So area, we have to choose 1 by 100. That's why 1000 kilogram weight. Okay. Kilogram weight is the gravitational unit of force. In SI system, we know 1 kilogram weight is 9.8 Newton, or you can round off it to 10 Newton. Okay. So 10 kilogram object will have a force of 10 into 9.8 Newton. That is nearly 100 Newton. 10 kilogram means 100 Newton. Okay. So we have completed paper 10 physics part. Thank you.